This video will discuss quadrilaterals or four-sided polygons. Basically, quadrilaterals can be divided into two main groups. The first group are parallelograms and the second are not. So for example, in the parallelogram group, we have the parallelogram, rectangle, rhombus, and square. In the non-parallelogram group, we have irregular, quadrilateral, trapezoid, isosceles trapezoid, and then the kite. Let us note that trapezoid and trapezium both refer to the same quadrilateral, and also isosceles trapezoid and isosceles trapezium also refer to the same quadrilateral. Each special quadrilateral has its own sets of properties, some similar to other quadrilaterals and some entirely different. For example, with the rectangle and rhombus, all the corner angles, interior angles are 90 degrees, but the rhombus and the parallelogram don't have 90-degree angles, yet they have pairs of equal angles. With the isosceles trapezoid, it can be divided into two equal shapes when a line is drawn through the midpoints of the parallel sides. So with this type of trapezoid, the non-parallel sides are congruent as indicated by the congruency marks. A kite too has two pairs of equal sides and then one pair of equal angles. As for the irregular quadrilateral, no side or angle is the same. Other special properties are created when diagonals are drawn in each special quadrilateral. For example, in a square, the diagonals bisect each other at 90 degrees. The same for the rhombus. However, for the rectangle and parallelogram, that is not the case. Now, these special properties which are created when diagonals are drawn also helps us to find angles and sometimes the lengths of certain sides depending on the question. So from time to time, you may have to refer to these diagrams to get a summary of the property that each special quadrilateral has and how it affects the angles and sides. Other interesting properties can be discovered when mid-segments of a quadrilateral are drawn. Now, what is a midsegment? A midsegment is a line segment that connects the midpoints of two adjacent sides of a polygon. Now, when that is done for a quadrilateral, special shapes are also formed. For example, in a parallelogram, the midsegment form a parallelogram. The same goes for a trapezoid or trapezium and irregular quadrilateral. For rectangle and isosceles trapezoid, the shape formed by the midsegments is a rhombus. For a rhombus and a kite, the shape formed by the midsegment is a rectangle, and a square forms another square when the midsegments are joined together. All these special properties helps us in identifying angles and sides depending on the nature of the question. A bimedian is the line joining the midpoints of two opposite sides in a quadrilateral, and this helps us to locate the center or centroid of the quadrilateral. How do we find the centroid of a quadrilateral? We will first have to locate the midpoints of each of the sides and then join the opposite midpoints together. The point at which they intersect is the centroid. Now, how do all these properties of quadrilaterals help us to solve questions involving angles? The following examples will show us how. In this question, we will apply the angle property of quadrilaterals. What is that property? It is the fact that the sum of the interior angles equal 360 degrees. That means that angle C plus B plus A plus the right angle here, which is 90 degrees, equal 360. The question also provides other hints to solving for B and then A. Angle B and 129 degrees lie on a straight line. That means that angle B plus 129 add up to 180 degrees. Also, angle A and 76 lie on a straight line, adding up to 180 degrees. So these are extra clues that can help us to solve for B and A. Then we can use the angle property of quadrilaterals to solve for C. So as mentioned earlier, the 90 degrees plus C plus A plus B equal 360 degrees. Again, angle A plus 76 equal 180 degrees as shown in equation 2. And angle B and 129 add up to 180 degrees as shown in equation 3. So we'll first find A, which will simply be 180 degrees minus 76, that is 104 degrees, and then B will be 180 minus 129 degrees, which is 51 degrees. Then we will substitute those values into equation 1 in order to solve for angle C. That gives us 90 degrees plus C plus 104 degrees plus 51 degrees equal 360 degrees. Then we will solve for C, which will be 360 degrees minus 245 degrees, or 115 degrees. In this question, we will not have to do a lot of calculation because we are given other hints that will help us to solve for the angle A. What are those hints? Firstly, we know that this is a parallelogram from the fact that the two opposite angles are equal. So that means that angle 150 degrees and A will also be equal because they are opposite. So simply, without performing any calculation, angle A is equal to 150 degrees. We can always check our answer by adding up the angles together and confirming whether they sum up to 360 degrees. So doing our check, we see that the left hand side is 360 degrees and the right hand side is 360 degrees, confirming our answer. In this example, we will have to apply other angle properties learned from previous lessons. Firstly, we identify the object as a parallelogram by the two pairs of parallel sides. Looking carefully at the parallelogram, we see that angle X is 90 degrees because it is vertically opposite to this 90-degree angle at this intersection point. Then we can compute for angle Y, which can be found by summing these three angles to 180 degrees. So solving for Y, we get 87 degrees. Next, when we carefully examine the parallelogram, especially this diagonal, we see that this diagonal is a transversal because it cuts through these two parallel sides. That means that angles Y and Z are alternate interior angles. So if we have already solved for Y, then we'll simply equate Z to it